Hey geometry students, Mr. Zacek here. Welcome to Unit 1, Lesson 7. Today we're going to be talking about the distance formula. Now the distance formula is going to help us when we are on the coordinate plane. When we think about the coordinate plane, we're thinking about kind of that, our XY axes. And very similar to yesterday with the midpoint formula, we're going to have 2 points. So let me give you the formula first of all, that the distance equals the square root of x sub 2 minus x sub 1. That whole quantity is squared plus the y sub 2 minus y sub 1 quantity squared. Now to help remember this, what I like to do, I have this little song and it goes x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root to find the distance. Take the square root to find the distance. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root to find the distance. Take the square root to find the distance. Anyway, we could go on and on, but that helps me remember it. So make sure we're taking the square root of the whole thing. Helpful to note that with the distance formula, what's really happening in this first part, another way you could represent this is the change in x squared plus the change in y squared. That little triangle is the Greek letter delta, and that represents change. So whenever you have these x2 minus x1, y2 minus y1, that's really how this changes. So let's go ahead and see if we can work this out. So first thing we have here is, what is the distance between u, v, expressed in simplest radical form? We'll talk about that, and rounded to the nearest tenth. So the first thing I'm going to do is, let's add a little color into this discussion. I'm going to label this first point x sub 1, y sub 1, and the second point I'm going to label x sub 2, y sub 2. Now I'm going to write my formula. Distance equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And now we're going to substitute. And we have to be a little careful with substituting. We can get trouble with our signs. So uv now is going to equal the square root of x sub 2, which is 4 minus negative 7, quantity squared. Notice I put that second negative in parentheses, plus y2, which is negative 3 minus 5, quantity squared. All right, so as you see, there's a potential here for some sign errors. So 4 minus negative 7 is really 4 plus 7, so that's going to be 11 squared. Negative 3 minus 5 would be negative 8 squared. If you're putting these in the calculator, you want to keep those numbers in parentheses, because they will, squaring that negative, we want to make sure it becomes positive. So 11 squared is 121, 8 squared is 64. So the distance of uv equals the square root of 185. So it says we should write our answers in 2 different ways. And those 2 different ways are, we want to do them in simplest radical form, and we want to do it to the nearest tenth. So when we think about simplest radical form, we're looking for what is the largest perfect square that's going to go into 185. So if we kind of list out our perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196. We notice that 185 is not on that list. So this is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, etc. Okay, so 185, let's see. Is there a perfect square that will go into 185. Probably nothing before 100, maybe 49. 185, let's try 64. Not 64, I'm just putting these in my calculator. 185 divided by 49, no. 185 divided by 36, no. 185 divided by 25, nope. Divided by 16, nope. Divided by 9, nope. Divided by 4, nope. So I don't think there is a perfect square that goes into it, so that is simplest radical form at 185. And then what we would do next is put it into the decimal form. So we'll just go ahead and take the square root of 185, and that's going to be 13.6. So UV is approximately 13.6. So those are our two answers. It's the square root of 185 or 13.6. All right, let's move along. SR has those endpoints. What is SR in simplest radical form and rounded to the nearest tenth? We start off by labeling x sub 1, y sub 1, x sub 2, y sub 2. I'm going to write the formula. Just get this repetition. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root. Now that's the general formula, but specifically for SR, we're going to plug in. So it's going to be x2 minus 3 minus negative 2. Notice I put that negative 2 in its own set of parentheses. Okay, plus negative 1 minus 14 squared. So SR is going to equal, so 3 minus negative 2 would be 5 squared plus negative 15 squared. So SR is 25 plus 225. So SR is going to be 250. If you're ever doing this and you get a negative number, you know that you did something wrong, because when you square it, it's always going to become positive. So usually that error is happens when you enter things into your calculator. You don't put it inside of the right parentheses when you're squaring things. Okay, so this one is going to simplify, and we could rewrite 250 as 25 times 10. And so we could rewrite that as the square root of 25 times the square root of 10. The square root of 25 is 5 times the square root of 10. So that would be our answer in simplest radical form. And then in our calculator, we just take the square root of 250 to get our decimal rounded to the nearest tenth, and we would come up with 15.8. So distance formula, a couple different ways. All right, we got your reflection example there. So I would like you to do that question on your own here in this paper, just to give yourself some practice with these. So answer both of those, and we can go over that in class and make sure that we are working to study and remember the distance formula. All right, thanks class. Good luck.